To add in scientific notation form, let's review two things first. Looking at our green, 5 times 10 squared plus 2 times 10 to the negative first, I can write those in standard form. So 5 times 10 squared is 500, and 2 to the negative first is 0.2, and I would get 500.2. Looking at the original problem, I can't just do 5 plus 2 to get 500.2, and I can't just add, multiply, or anything with those exponents because we have no exponent rule for when I add with the same base. This is where the distributive property comes in handy with my orange problem. So I have 6 times the sum of 4 and 7. I can distribute this 6, and it would be 6 times 4 plus 6 times 7. And I can go the opposite way. If I see 6 times 4 plus 6 times 7, I see they both have a 6. So I can factor that out, and in parentheses write 4 plus 7. Keeping that in mind, when we add scientific notation together, we need to make sure that the exponents are the same. And looking at the problems above, I see that the first one is the only one that has the same size exponents. So because they are the same size, I can just look at the mantisas and add them together. And when I add decimals, I have to line them up. So 4 plus 5 is 9, 3 plus 7 is 10, and I bring down the decimal place to get 10.9. So I get 10.9 times, I keep the power the same, whoops, I get 10 to the 8th. Now you should know that that's not in correct scientific notation form, and I need to make the mantissa smaller by 1 decimal place value, so I got to make the exponent 1 bigger, making it 1.09 times 10 to the 9th. This middle one in purple, I notice that I have an exponent of 5 and an exponent of 6. What I like to do is I try to match the exponents to the bigger one. That way the end result, I am less likely to have to convert into scientific notation like I had to do here. So between 5 and 6, 6 is bigger. So to make 3.7 times 10 to the 5th, to be 10 to the 6th, 1 bigger, I have to make the mantissa 1 place value smaller, so 0.37. Now my exponents are the same, and I can just add the decimal places together, lining up the decimal points. And I get 2.47, and I can keep the power the same. And my final answer is 2.47 times 10 to the 6th. Notice how it's incorrect scientific notation form. Had we made both exponents 10 to the 5th, I would have had to convert at the end. Now this last one, I notice I have 10 to the negative 5th and 10 to the negative 8th. So I can't just add those mantissas together because those exponents are different. Negative 5 is bigger than negative 8. So I'm going to make this number to have a power of 10 to the negative 5th. Because it's 3 place values bigger, I'm going to make my mantissa 3 place values smaller. So I did 1, 2, 3. Now I can just add the mantissas together. 5.919 plus 0.0068, and I get 5.1968 times 10 to the negative 5th power, and it's already, whoa, you don't want to see that, and it's already in scientific notation form. So exponents need to be the same. If they're not, make the exponents match the largest exponent to make it, and then just add the mantissas together and finish it off in correct scientific notation form.